So today we're looking at polynomials and specifically adding and subtracting polynomials. To understand what a polynomial is, we have to understand what a monomial is. Monomial has the word mon in it. What do you think that indicates? One. Right. So before we add or subtract anything, we're dealing with a monomial. Okay. As soon as we introduce addition and subtraction, then we're dealing with a polynomial. More than one, right? So it says a monomial is a number, a variable, or the product of a number and one or more variables. So for example, it could be the number 1, it could be the variable x, it could be the product of a number and one or more variables, so it could be 3xy with whole number exponents. And that's important. The big thing that people seem to forget in identifying monomials and polynomials and what makes a monomial is the little things, the little details. And one of those little details is that you have to have whole number exponents. So for example, and I'm going to underline this, whole number. This is an example of a monomial. That's just the number 2. This is an example of a monomial, 2x. This is an example of a monomial, 2xy. This is an example of a monomial, 1/2 xy. This is not a monomial, okay? 1/4 x. And you'll learn about what that 1/4 means in Algebra 2. We skipped over that section for a very specific reason, and that's because you're going to drill into that in Algebra 2. So here, and I'm going to mark it out in blue here so don't get confused. This is not a monomial because it has an exponent that's not a whole number. It's a fraction. It's an integer, but it's not a whole number. Remember, whole numbers are 0, 1, 2, 3, 4, 5, 6, 7, 8, etc. Also negative exponents. Okay, it does not include negative exponents. The degree of a monomial is the sum of the exponents of the variables in the monomial. So, for example, if we're looking at 2xy, that's x to the first, y to the first. So the degree would be what? Nope. 2. Right. And this is very important because when we look at the degree of the polynomial versus the degree of the monomial, those two things are different. And I always got confused with that when I was in school. I was like, what's the difference? I don't remember. But there is a difference. Okay, so when we're talking about monomials, meaning there's no addition and subtraction, and I'm talking about the degree, you're going to take the powers of the exponent and you're going to add them all up. So 1 plus 1 is 2, so the degree here is 2. Now, it says the degree of a non-zero constant, so for example, just the number 2, is 0. Why would that be? I don't see an exponent attached to it. I don't see a variable attached to it. Why would I have the constant 0 as the degree? Is it because I don't have an exponent? Any idea? What's another way I can rewrite 2 with a variable and an exponent? With a variable. 2x not to the first. To the 0. Right, because anything to the 0 power is 1. So because I do have an exponent raised to a variable, but this time the exponent is 0, that's why the degree of a constant, 1/4, 3, 5, 105 is always going to be 0. Does that make sense? Yes.
Is the degree always going to be added?
Only for monomials. And that's the thing that everyone forgets. I even forget that. I forgot that a lot in school. Monomials, you add them together. Polynomials, you look at the highest one. And we'll look at that. But yeah, that's a very good question. And that's something that a lot of people mess up. So hopefully you don't mess that up. But I understand if you do, because I did. Any other questions about what a monomial is before we talk more about that? Yes? Well, 2 to the first, but I'm looking at the exponent of the variable, not of the constant. Yeah? That's a good question. So here we have a chart that gives you several examples of monomials, and this is a very useful chart to write down, just to look back at when you're studying for the future, because like I said, once we get deep into chapter 7, it's easy to forget the degree of the monomial. Now it's okay, because that's all we're looking at. But in the future, when we start looking at polynomials, binomials, and trinomials, you might forget how to actually calculate the degree of a monomial. So the first one, 10, is a degree of 0 because it is a constant, and all constants have a degree of 0. 3x, well, x is raised to the first, so that has a degree of 1. 1/2 ab squared. That degree is 3 because a to the first, b to the second, 1 plus 2 is 3. And then negative 1.8 m to the fifth, the degree, of course, is 5. Now look at the examples that are not monomials. And notice that they have to do with the variable and what's happening to the variable, not the constant. Okay? Because even though we can have a constant that's a fraction and still have a monomial, like we have 1/2 ab squared, we cannot have a fraction that is an exponent. So for the first one, 5 plus x, as soon as we introduce addition or subtraction, we're dealing with a polynomial, not a monomial. The next one, you cannot have a division of your exponent. So n to the first is in the denominator. Well, n to the first in the denominator, that can be rewritten as, so if I have 2 over n, that can be rewritten as 2 to the negative 1. And we cannot have negative 1 as an exponent. We have to have whole number exponents. Whole numbers are positive numbers, including 0, not fractions. The other thing we can't have is a number raised to an exponent. So 2 to the x. Those exponential functions that we talked about. 4 to the a, 4 to the x. And then, of course, the last one is x raised to the negative 1. We cannot have a negative exponent. It's not a whole number. So that is not a monomial as well. Do you have a question about what makes a monomial and what does not make a monomial? First one, what's the degree? 2. What's the degree for B? 4. The degree for C? 6. And the degree for B? Because you have 1 to the third plus x to the first. So third, 3 plus 1. It's going to be 4. Okay. I think the next slide is some examples, so just for the sake of the video, I'm going to go to it. We're not going to do it because I think you have a pretty good understanding of this. Yeah. So if you do need these extra examples and you're watching the video, just pause right now and work on these. And then I will go ahead and reveal the answers to those. Okay. Polynomials. Alright, so this is a very important slide. We're jumping into polynomials, and throughout the rest of algebra, and definitely in Algebra 2, pre-calc, and beyond, you're going to be dealing with polynomials, monomials, specifically binomials, trinomials, etc. Okay, so what is a polynomial? A polynomial is made up of more than one monomial. It's a monomial, so it can be the monomials that we looked at, or a sum of monomials. So, in other words, every monomial is a polynomial, but not every polynomial is a monomial. That's what that's saying. So while we have, for example, 5x, which can be described as a monomial and a polynomial, 5 plus x can only be described as a polynomial. Does that make sense? Okay. So each monomial is called a term of the polynomial. So for a binomial, you have two terms. The one in blue is a linear function, meaning it forms a what? A line in two terms, and those two terms make a binomial, bi meaning two. A polynomial with three terms is called a trinomial. So for example, x squared is one term, one monomial. 5x is another monomial, and 2 is another monomial. So three of them make our trinomial. Now sometimes our trinomials and binomials, etc., have special names. For example, and the book doesn't talk about this, but it is very important to know. I'll write it out to the side here. So we describe x, like x to the first, like 3x plus 2, 2x plus 5, 1/2 x plus 1. We say that's a linear function. Anything with x squared in it as the leading coefficient, meaning the highest exponent. We also call that quadratic. And you will hear that word all the time. And what you should automatically think, because there are several things you should automatically do when you get out of this class. And one of them is when you look at x squared plus 5x plus 2, think to yourself, that's a quadratic function. And eventually we're going to see what that graph looks like as a parabola. X to the third is called a cubic function. X to the fourth is called a quartic. X to the fifth is called a quintic. Those you don't really need to know. But definitely, x to the first, linear, x squared, quadratic, x to the third, cubic. Now the number of terms that make up the linear function, the quadratic function, and the cubic function determine whether or not it's a binomial or trinomial, etc. Beyond that, we'll just call it a polynomial. A polynomial of how many terms? So the degree of a polynomial, and this is where it differs from the monomial, is the greatest degree of its terms. So in our example, you don't add 3 plus 2 plus 1. You just go by the 3. That's what makes it different from just looking at a monomial. Does that make sense? So we say this is a polynomial of degree 3. That's something, again, automatic. You should be able to look at any polynomial and say what degree it is. Oh, it's a degree 3. The other thing that you should automatically do from here on out is put your polynomials in standard form. That means that starting from left to right, because that's how we read mathematics, you have the highest exponent coming first, then the next highest, then the next highest, etc. You should always reorder them so that they are in standard form. Because everything that we do, every mathematical tool that you're going to get from here on out, is going to require you to work with a polynomial, not every, but a lot of them are going to require you to work with a polynomial in standard form. So automatically you should reorder them. When you write a polynomial in standard form, the coefficient of the first term is a leading coefficient. A lot of people, a lot of math teachers, and a lot of math theorems that you'll learn, especially in Algebra 2, have to do with the leading coefficient. Something about the leading coefficient is going to help you solve the problem or graph the equation, etc. So you need to know what a leading coefficient is, what standard form of a polynomial is, and how to read the degree of the polynomial. Do you have any questions about this slide? All right. For this slide, it says write the polynomial in standard form. So again, we want to start with the highest degree of our exponent. So that would be x to the third, right? There is a negative in front of that x to the third, so we have to remember that as well. So we have a negative x to the third. And then what comes next? 15x, so plus 15x plus 3. What's our leading coefficient? -1. Coefficient is just a number. So the leading coefficient is -1. Is this a binomial, trinomial? It's a trinomial. It has 8 terms. Is this cubic, quadratic, or linear? Cubic. Yeah. Does that all make sense? All right. As far as the next couple, you have -3z to the 4th. So write it in standard form. It is in standard form. There's nothing we can do about that. Identify the degree. What's the degree? 4. And classify based on the number of terms. So it's still just a polynomial. Well, it's a monomial, right? Monomial. It's just a monomial. Monomial. Degree 4. All right. Writing this one in standard form. 5x squared minus x plus 4. Leading coefficient is 5. Classify based on, or identify the degree. Okay, so what's our degree? 2. Degree is 2. Say monomial, binomial, trinomial. Trinomial. Is this linear, quadratic, or cubic? It's a trinomial and it's quadratic.
Why is the degree?
You go by the highest degree for a polynomial. The highest degree is the 2, is the square. Is that 2? Because you have the first, you have to the 0, x to the 0, right? So again, with our polynomials, that's different than monomials. Monomials, we add them up. Polynomials, we look at the highest. That's why it's confusing. It's confusing for me too to remember. Polynomials, you have to remember you're going by the highest one, and then you have to reorder it in standard form. It's of degree 2. It's a trinomial, and because it's of degree 2, that makes it quadratic. Trinomial. Without my N. There we go. Thanks. Okay. How would I reorder C? Q to the 5th plus 8Q. So Q to the 5th plus 8Q. Now, one important thing to notice about this, that we'll talk about later on in future slides, is that you don't have the 4th power represented, the 3rd power represented, or the 2nd power represented, right? And when you move into higher level mathematics and you do division of polynomials and things like that, and even in addition and subtraction, you have to remember that you don't have those things represented, those powers represented. So you would just put 0 q to the 4, 0 q to the 4. You don't have to here, because we're not at that level yet. It's of degree what? Yeah. Remember what this is called? It is a binomial. Okay? Remember the special name for it. Bonus points for you. It's not quadratic. It's not quintic. No, yes, quintic. Yeah. Quartic is 4, quintic is 5. You don't have to remember that. But quintic. Okay. Questions on this? All right. They were just talking about, here on this slide, it just, again, gives exactly what I said: monomial, trinomial, binomial, and the different degrees, and written in standard form. So, for this slide here, just pause the video, give it a try. These are the answers to 5, 6, and 7. Binomial, trinomial, binomial, Remember, we added an extra layer here, so this is linear, this is cubic, this is also cubic, and then everything written in standard form. Remember, you have to carry that negative through for your leading coefficient. All right, questions on that? Yes.
So the coefficient is just going to be the first number.
Yep, so you have a coefficient of negative 10 here, coefficient of positive 1, yeah, coefficient of 1. Now the leading coefficient is just the first one. Yeah, I think I've used that term rather loosely throughout the semester, and I should have just grounded it in you guys a little bit more. It is just a number in front of the variable. So our coefficient is 1, like I said, negative.
So if there's just a number, then it will always be.
Well, if like 4, you can think of 4x to the 0, right? So 4 is the coefficient here.
I mean, if there's just a variable.
If there's just a variable, yes. Yeah, and 4 we actually just call a constant, right? If there's just a variable like x, then it would always be 1 for that coefficient. Or negative 1 if there's a negative in front of it. Yeah, great point. Okay, I'll tell you what to write down here. Alright, if you're watching this video, take a look at what closure means. I will ask you about closure most likely as a bonus question on a test. I will most likely ask you if a certain number set, like whole numbers, integers, real numbers, for example, are closed under a particular operation. So, no matter what I do, for example, if I add two integers, I will always get an integer. So they are closed under addition. Integers are closed under addition. Any questions about closure? I mean, it's really not a thing that you really need to get in Algebra 1. Like I said, I never really understood what closure meant until college. It's just a thing that is important to know. A property that is important to know. But not crucial. Not like the last slide. Last couple slides. Okay, finding the sum. I'll show you how we do this. So copy down A, and then we'll go over it. Let me finish with this slide before I let you guys go for the day. Finding the sum is not that hard. You can do it in two different ways. One thing you can do is make sure they're in standard form. Always has to be in standard form. And then you can just stack them on top of each other and add, which I think that's what they do here. It's called the vertical format. This, typically with addition and subtraction, I don't stick to the vertical format because it's pretty easy for me to add and subtract, and probably pretty easy for you to add and subtract. Just add the x cubes together. So 2 and 1 make 3. And then you have a negative 5x squared and a 2x squared. Combine those. So you're just practice combining like terms. Yeah? Now, what this vertical format does is it does allow you to look at what's missing here. And again, that is very important, especially as you transition into Algebra 2. What powers are not represented? Notice they don't have an x to the first here, so they just leave it blank. Or you could just put plus 0. They add straight down. 2 and 1 make 3. Negative 5 and 2 make negative 3. 1 and 0 make 1. So you just have 1x. And then you have that minus 1. No, because they're not being multiplied. Remember, you only add exponents when they're being multiplied together. You're just combining their like terms through addition. Same thing is true for b. If you can't see b, I have it on the next slide. They don't do the vertical format, they do the horizontal format like I just said. And I'll move that over here. Just group like terms. 3 and 1 make 4. 1 and 4 make 5. 10 and negative 6 make 4. Questions on that?
Can you go back to the first one?
Yes.
Oh, then go to
Yeah. I'll go back to the first slide. Alright, you guys still have some minutes, so I don't know why you're all packing up. Do remember, if you did not turn your homework packet into me, I need to have it by the end of the day at the latest. I will not be here for too long, so try and find me. I will be in 6:03. I'll be in 6:03 during lunch. I'll be in 8:06 during break. You need to find me then. All right, and then for that last one, just combining like terms, and then putting it in standard form. Yep. We'll start here tomorrow. Tomorrow, maybe a little bit of 7-2, and then a lot of 7-2 on Friday.
This one is still.
I know. Thank you.